We are live. Hello everyone, welcome to Microsoft Build, Unpack the Tech, Azure Cosmos DB Elasticity Deep Dive, one of these sessions with the world's longest title. Today is all about deep diving into the cool features from Azure Cosmos DB that were announced over Build. Now, with all reactor events, we do have a code of conduct that we expect everyone to follow. This event, we encourage you to get involved in the chat, ask your questions. Everybody here will answer anything you've got, but we do ask that you follow our code of conduct. You can read the code of conduct here, but essentially, please be respectful and keep your comments on topic and relevant to the conversation. And with that, I will miss the next slide. This session is being recorded and it will be available in 24 to 48 hours on the Microsoft Reactor YouTube channel, as well as on the Cosmos DB YouTube channel. So any questions, please ask your questions in the chat on whatever platform you're on. If you're in the room, raise your hand, ask the questions, we'll make sure that we get you. And with that, I will kick off the event and hand you over to our presenters. So do you two want to introduce yourself?
Sure, thanks so much. Hi everyone, super excited to be here. My name is Deborah Chen and I'm a product manager on the Azure Cosmos DB team working on a lot of these features that we'll talk about today.
Hi, I'm Justine Cocchi. I'm also a product manager on the Cosmos DB team, and I'm really excited to share these elasticity features with you all today.
Awesome. Well, thank you for coming. Thank you for joining us for this. So this session is all about diving into the features that were announced at Microsoft Build. So Microsoft Build, our premier developers conference, we announced a lot of new stuff. So very quickly, in like 10 seconds, what's the new features that you're going to be showing off today? You mentioned elasticity.
Yeah, so there's actually 5 sub-features in there, and will be a super heavy demo-heavy session. So we'll have some slides to explain it, but mostly will be in Visual Studio and in the Azure portal. So we have a ton of features to help you get better scalability, better cost and performance, better optimal partitioning, and just overall help you scale no matter how big or how small your workload is.
Nice. So Cosmos DB always talks about being a global scale database. Yeah, it's not me storing my shopping list on my computer. It is if you want something that replicates all around the world and scales up. So these features allow more in that space, allow us to scale up even more, grow it even more. Nice, this is exciting. I'm going to hand over to you two because you two are the experts. So take it away, amaze me, and I'll keep diving in with questions as we go through.
Thanks so much.
Thanks, Jen.
All right. So we'll give a quick, just high-level summary of all the features we're going to be talking about today, and then we'll dive right into the demos. So the first feature that we have is we actually expanded our serverless offering to let you store containers of up to 1 terabyte in size. So serverless is really great for use cases where you, actually if you have a shopping list, not a lot of data, you don't use it that often, you can store it in Cosmos DB, and you will only get charged if you actually send a request or consume any request units on the container, and for the storage. So if you're not using it, it's basically free and idle.
So this is kind of like Azure Functions. So Azure Functions, you only pay for the consumption, actually when it's running the function. This is the same thing, you're only paying when Cosmos DB is actually accessing data. Yeah. If you're doing nothing, so if you've got like a business that runs 9 to 5, you don't do work after 5, you don't pay.
Exactly.
Nice, I like it. We like saving money.
Yeah, so by default, previously, the maximum data size you could store in the container was 50 GB. Based on our customer feedback, we've now expanded this to 1 terabyte in preview. So if you have larger workloads that still don't need a lot of throughput and don't have a lot of activity, with higher storage, this is a great offering you can try out. Now, for customers who are using provisioned throughput or have workloads where you actually need dedicated, consistent throughput to serve those mission-critical workloads, we have a lot of features to help you optimize and get better cost and performance. So a new feature in preview called Hierarchical partition keys, which allows you to partition optimally for multi-tenant scenarios or scenarios where you'd otherwise use synthetic keys. So you'll get better data distribution, which means that your queries will also be more efficient. We also have a feature that allows you to fine-tune or optimize the number of, or the layout of your physical partitions so that for the same RUs that you provision, you can actually get better performance per partition. This has actually been one of our top requested customer features over the years, especially for larger customers who have a lot, like really large workloads that they want to optimize. So we're really excited to demo this today. The engineering team has worked super hard over the past few years to bring this to reality. We also have a couple features to help you further fine-tune and optimize the RUs that you can consume on your workloads. So burst capacity allows you to take advantage of unused capacity to spike. If you have unpredictable spikes of traffic, you can handle those now with your unused capacity. And we have another power user feature that allows you to set different RUs across physical partitions if you have a hot partition that you want to correct for. So this is the high-level overview. We'll now dive right into the demo, starting with hierarchical partition keys, also known as subpartitioning.
Cool. So what are hierarchical partition keys? So we already kind of mentioned some of this, but just to recap, so with hierarchical partition keys, you are now able to partition your container on up to 3 levels of keys. So previously, you pick your one partition key and that's sort of it. And there maybe are trade-offs, maybe there's some queries that are cross-partition, and there's not much you can do about that. So now with hierarchical partition keys, you can have up to 3 levels. This also allows you to exceed the 20 gigabyte maximum data limit for your partition prefixes. And queries by these prefixes are still routed to the subset of relevant partitions. So you still get super efficient queries with this more fine-grained partitioning strategy. So what scenarios is this really good for? This is great for multi-tenant workloads. So say you have a tenant ID, but you also have some other property that you want to partition on, maybe a customer ID. So within your first level would be tenant, and then you could have your customer ID as your second level in your hierarchy. And you can have up to 3 of those levels. And this is also great for workloads that are currently using synthetic keys. So instead of having a synthetic key, which is a property that you basically concatenate 2 values, yourself in an extra property, you can natively do this with hierarchical partition keys today. So that's enough explaining what they are. Let me just show you. So I'm going to pop into the Azure portal. I have a database here called my hierarchical keys demo, and I have 2 containers. I have one container for my synthetic key and one for my hierarchical key. So first, let's take a look at my synthetic key container, and let's see what one of these documents looks like that I'm currently storing. So in this scenario, I am a online retailer handling a bunch of transactions. So I have some properties here. We have our transaction ID for this document. We have our store ID, so what store was associated with this actual transaction. And you see here, this is the partition key for my container. So I've created a separate property called store ID, transaction ID key. And you can see the value of this property is 109, which is my store ID, semicolon, my transaction ID. So the reason that I've chosen a synthetic key for this partition is the queries that will be issued against this container primarily revolve around my store ID, but I only have 500 stores. So that's a pretty low cardinality property, right? I don't have that many potential values. So if I partitioned on store ID alone, well, it would be great for my queries. I might fill up 20 gigabytes of data for a given store, or I also might just not have a very even distribution, right? Who's to say if all of the hot stores end up on the same partition and then your application can't scale as well as it should. So in order to fix this, I have a second container with the exact same data that is actually partitioned on a hierarchy. So let me open this one more time and expand this. So you can see now we have hierarchical keys, and the first level of partitioning is actually on store ID, while the second level is on transaction ID. And if I open one of these documents, you can see the schema is exactly the same. I even kept around this old store ID, transaction ID key property, but this partitioning allows us to get much more efficiency out of our queries. So let's take a look at what a query will actually look like. I'm going to open a new SQL query. This is against my synthetic key container. And I just want to see all of the transactions for a given store. So let's say select star from C, where C dot store ID equals, let's just pick one of our stores. Let's pick store 300. So if we hop into our query stats here and scroll down, you can see this query costs about 40 RUs. And I also want to dig a little bit deeper into what's actually going on under the hood of this query. So there's a really cool feature called the per partition query metrics. You can just download the CSV right from the portal. And let's go ahead and open this up and let's see what's going on behind the scenes. So let me zoom in. Oops, too much. So it's a little bit easier to see what's actually going on. So when I created this container, I created it to have 10 physical partitions. So you can see here, my partition key range ID is from 0 to 9. So 10 physical partitions. And with this partitioning strategy, I actually have documents for the store across all 10 of these partitions. And we can see here the amount of data that was retrieved, the output documents, and a bunch of other great data. If you want to really debug this query and see what's going on, you can see how many of these documents were served from the index. We can see the lookup time in milliseconds, as well as the document load time, the query engine time. There's no system functions in this query, no user-defined functions. So there's really a lot of great data here. But the point I want to drive home is that for this query, we had to look at all 10 of our partitions. So let's go back into the portal. And this time, let's issue the exact same query, but let's issue it against our container with hierarchical partitioning. Oops. So I'm going to say select star from C, where C dot store ID equals 300. Now, when I execute this query and I look at the query stats, you can see this request only took 12 RUs. So with the exact same number of documents, we got much lower RUs for the same query. So what this means is now with hierarchical partitioning, your queries that used to be cross-partition are now scoped, and you can actually run more of them for the exact same provisioned RUs that you already had previously.
So question for me. So
yeah.
Just trying to comprehend this in my head. I'm thinking about the use case of a store. I might want to do reports on my store data.
Mm-hmm.
But then think about the use case of analyzing a particular transaction that happened, and I will actually search for a transaction. So before, when it was the multi-part partition key, if I would say, give me all for one store, it couldn't just use that partition key because it doesn't know how to look it up. Or if I wanted one transaction, again, it couldn't do that. So it's a lot more expensive to do kind of what seems to be like two standard use cases. But now with this, if I want to look up a particular customer order, because of multiple partition key, I'm literally hitting that primary key almost, thinking of it in like SQL terms. I'm hitting that primary key and I get it straight away. Or if I want to do a store report for giving my numbers for the past month or past quarter, I'm getting that straight away because I'm hitting that key. This is kind of giving me that level of power.
Yeah, definitely. So now you're able to query by partition prefixes or the entire partition key. So if you wanted to get just a single transaction, you still would need to provide the store ID as the first part of your partition prefix, right? So you need the whole partition key still for the transaction ID case, but it allows you to search by store ID, say you didn't want to filter to a specific transaction, and you're able to be a lot more efficient in that. So for each prefix set, it gives you increased efficiency.
Nice. So it's like so think back kind of SQL terms because the last semantic database is SQL. This is like building up like a multi-part primary key essentially.
Yeah, exactly.
Yeah, nice. I like it. Because RU is obviously cost money. That's one of the confusing things about Cosmos DB pricing is you pay per RU, and I still don't know what they are, but that's like the cost. That's like how much power you have to use to do the thing. So it's not like you pay per query, you pay based off how much, almost like how much CPU time is being used.
Exactly, yeah. RU is just an abstraction on top of CPU, the query engine time, so how much time did the actual query engine spend serving all of these columns, query execution time, system step function execution time, document load time, index lookup time. Your RUs is just an abstraction over all of the time and work that it takes to serve your request.
Okay, so thinking about how a team might want to optimize their costs, it actually is financially beneficial to put the time into doing things like hierarchical partition keys to make their queries more efficient. But in terms of, if I'm a developer and I see my code running slowly, I can actually go to my boss and say, my code runs slowly, it costs more money. It would actually save you money to pay me to optimize the query because I've got this kind of one-to-one direct cost mapping.
Yeah, exactly. As a distributed database, Cosmos DB, the way that Cosmos knows which of your physical partitions to look at is the partition key. So this is one of the critical components to having a successful application with Cosmos DB, and really taking time to get your partitioning right will definitely save you money in the long run.
So that does lead to one other question, saying about taking time to get your partitioning right. can you change partitioning? So if I've got a database already set up with my synthetic partition key, and I want to then port that to use a hierarchical partition key, can I do that? It's like a one-click add new partition key, or is this a case of spin up a new database and migrate my data?
I think that's something we'd definitely love to do in the future, but for now you do have to create the new container because you're basically essentially repartitioning all your data, right? Before, based on the synthetic partition key, Cosmos DB stored your data on one partition. Now this new partitioning strategy, it should be probably somewhere else. So it's essentially when you create the new container, move all your data over. We have some tooling to help you use Azure Data Factory. We have some Spark tooling. We have some live migration change tree tooling as well to help you do that.
Right, so it's not just like I'm creating an index, it is we're literally moving data because these partitions map to some form of storage somewhere. So they literally have to move data, which makes it more efficient to search because you're not zipping across disks.
Right.
But so you have to move data, which means it's a big piece of work. So it's a proper migration strategy, not a click, click, click.
Yeah.
Cool. Good to know, thank you very much.
Yeah, of course. So as you can see, this is the query per partition metrics for the query against a hierarchical partition. So you can see here, all of my data now actually only lives on one partition. So this is great. Cosmos DB knows exactly where to look to find my data and serve my request.
I guess one other cool thing about this, relevant to actually an event that I was at a couple of days ago, and Matthew from our audience here was at a couple of days ago, that's a Green Software Foundation event. By hitting less partitions, that's slightly more environmentally friendly because you're using less energy, there's less wear and tear on hardware. So this is kind of another small change that saves you money and again helps towards kind of any sustainability software targets.
Yeah, definitely. That's a very great point. We love that.
If you want to quantify the actual savings, each physical partition that you check has a typical overhead of 2 to 3 RUs. So for every physical partition, all those 9 we're not checking, we're basically saving 9 times 3 is 27 RUs, which means that either for the same provision throughput, you can run more queries per second if each query is cheaper, or you can actually lower your overall provisioning and get the same number of queries per second.
Yeah. So one other thing that we wanted to show you with the hierarchical keys, you might be thinking, oh, this is so great. How do I get that? So I'm going to show you, there's actually no way to create a container with hierarchical keys through the portal today. You have to use the .NET or Java SDKs. So let's hop into our VM where we have a data generator. Let me just make sure we're in the correct project. Here we are. So here we have a console application that will show you how you can use the .NET SDK to actually create a new container that has a sub-partitioning strategy. So in this example, on line 13, I'm creating my Cosmos client. Then on line 16, here, I'm setting up my hierarchy. So in this example, we're going to start with tenant ID. We'll go to user ID as our second level, followed by transaction ID. It's important to note that you do need this / prefix for all of your sub-partition paths in order for Cosmos DB to know this is actually a path. And then from there, we get our correct database, and we can actually make this call to create the container.
So how many levels can you go? I mean, you mentioned 3 in your original demo. Sorry, 2 in your original demo. Now you're doing 3.
Yeah, 3 is the maximum. So you can have up to 3 levels for your container. Yeah.
Nice, nice.
Cool. So now I'll just get out of this VM, and we can talk about another new feature that we have.
Cool, thanks, Justine. So now that we've optimized our partitioning strategy, we can start looking at how to optimize other areas of our workload. So as we all know, when we have workloads that are running in production, sometimes requirements will change. Sometimes before we may have needed to store a year of data, now we only need to store, let's say, 3 months. So I can actually delete, we might want to delete a lot of data. Or sometimes maybe we scaled up really high in the past because we needed a usage, but now with our current traffic patterns, we actually don't need that many RUs. So for both of these scenarios, with this preview feature of partition merge, you can now merge or reduce the number of physical partitions in place for your workload. The physical partition, roughly think of it as a server that holds your underlying data. In general, the more RUs you provision, if you tell us you need 1 million RUs, which is a lot of RUs, we'll provide enough partitions or compute to actually handle that, right? But if you scale up really high, let's say you started at 1 million, but realize you only needed 10,000, there's no need to have all those wasted partitions around. We can actually reduce or defragment those partitions. At the same time, if you have a lot of partitions because you have a lot of storage, so you have a terabyte of storage, which could be around 20 partitions or maybe a bit more than that, but then you go down to 50 GB. No reason to keep around 20 partitions when you only have that small amount of data. Right, so the real benefits are the reason you'd want to care about the number of partitions and underlying compute is today by default Cosmos DB distributes your RUs equally across all the partitions. So if you have a ton of partitions you're not using, but you still have to provision RUs for them, then you're basically wasting a lot of RUs, which also leads to higher costs. So by collapsing or reducing the number of partitions, we can get better cost and also better performance, since you have to check so many partitions if you have the cross-partition work. All right. So the way that you access this on your account is after you've enrolled in the preview, we'll go into the portal, and we have a PowerShell and CLI command that you can use to run this in place. So we'll go to our merge container and just take a look at our current scale and settings. So I currently have this collection provision at 50,000 RUs auto scale, which scales between 5,000 and 50,000 RUs. So this will have 5 physical partitions underneath, which can actually store 250 GB of data. And if I want to verify the number of physical partitions I have, I can go to my metrics. So you'll go to metrics down here, look at the normalized RU consumption metric, which tells you how much are you actually using on these partitions between 0 and 100%, split by the physical partition ID, and see we have 1, 2, 3, 4, 5 physical partitions. This is a fact. Each physical partition in Cosmos DB can do up to 10K RUs of throughput and store at most 50 GB of data. So 50,000 RUs, 5 physical partitions here. Now let's say we realize that we actually don't need 50,000 RUs. Maybe my requirements have changed and I want to lower the cost and reduce the RUs. Let's say instead I realize I only need 5,000 RUs. So now we have 5,000 RUs with the same number of partitions. We don't need all of that. So let's merge and get those partitions back. Now in real life, it takes some time to merge, so we have to actually move the data around compact. So I won't run that live, but I will show you a simulation command you can run to see what the impact of running the merge would be if you chose to continue. So I'm going to go to this built-in, very handy PowerShell command here. And I think because some time has passed, I need to set this context again. I'm just going to switch the context of my subscription, and I will show you the PowerShell command you can run to simulate what a merge would do to the number of partitions. So we have this command here. Which is called invoke Azure Cosmos DB single container merge. We have one for MongoDB or API for MongoDB containers or collections as well. So you give it your account name, resource group, your database or collection. So I'm going to give it my merge container that we just saw earlier, and we pass this what if flag. So this doesn't actually run the merge, it doesn't move any data. Cosmos DB doesn't do anything. It just calculates what the impact would be if you were to merge. So we have 5 partitions with 5,000 RUs that can go down to 1 partition. So this will take some time to calculate as it's figuring out the best way to redistribute your data to get your new throughput requirements. So we'll give this a minute, but it'll tell us how many partitions we expect to have afterward.
Nice, so you literally simulate it. It's,
yeah.
I'm not going to do it, I'm just going to play it, have a play, find out what this is. And
Yeah.
I guess going back to the question I asked earlier about if I do this action, how much would it save my company? This is kind of a great way to say, we've cut it down, this is what we can do, this is what savings we're going to get, before you then actually go ahead and work with your site reliability engineers or your ops people to actually run this command.
Yeah.
Nice. Quite a cool thing to have, because not much cloud stuff has got I want to see what happens if I do this, but don't actually do it. Yeah, it's nice.
So what if I wanted to actually run this merge? Is it the same command?
Yeah, so you'll just get rid of the what if, and then it'll also ask, like, are you sure? Because once you start it, Cosmos DB is literally moving your data around, so you can't really cancel or undo that. So I'll ask you, are you sure? We can see here this is finished. So before we had 5 physical partitions. It's saying if you were to merge, you can just have 1 physical partition, which makes sense. With 5,000 RUs, you can each partition can do 10K, so we just need 1. And I have a very small amount of storage here, so all my storage that I had is actually going to fit on that 1 physical partition.
Nice. Now, you say when you actually run this, things will start moving around. If I'm running this live, does it break anything? Does it switch off my database until it's finished?
That's a great question. So one of the reasons why this merge feature was such a big effort for the engineering team to work on was that we wanted to make sure that we could do this in place and allow customers to maintain high availability, have the database on, have their applications running at the same time. So to that end, we made some changes in our CosmosDB.NET client SDKs, which actually can handle, if you try to talk to a partition that's being merged or no longer exists, and you run a query against it, can you make sure you still get the right result, right? So as long as you are using the merge-proofed, as we like to call it internally, version of the client SDKs, and you're on SQL and Mongo API, and when your account meets our eligibility criteria, as long as you're using those SDKs, your app will continue to run while the merge is happening, and you don't have to think about it.
Okay, so in terms of planning this, I want to produce this. Step one is I need to work with engineering teams to make sure we've upgraded to the latest SDK and then roll that out everywhere. Do that first, and then I can run my what if, get my numbers, or even run the what if first, I suppose, but then not actually do the merge until we've updated everything. Is there a way to find out whether Cosmos DB is still being called by an out-of-date SDK? Because that seems to me that I've worked in like banks, for example, where there's mission-critical systems running on a machine under someone's desk and no one's even got the source code. So I always get cautious of we have to update everything. Is there a way of finding out what hasn't been updated?
Yeah, it's actually an amazing segue. I feel like you must have.
I would like to say this was not intentional. If it is a good segue, it's pure serendipity.
Yeah. So we actually have some built-in tooling in the portal to check whether an account is eligible for the preview, which checks a bunch of features, but also it checks all your SDK usage in the past 90 days. So the way you can access that is in the portal, go to your account. So I'm just picking one of my random accounts, Cosmos Autoscale Demo. Go to this diagnose and solve problems blade. Scroll down to throughput and scaling. So that's the area where all of our features are in. Go to throughput and scaling. And the nice thing about this blade, which I think it's not something a lot of customers know about, but it is pretty helpful. You can look at all of the built-in self-help for each feature, and we have some insights and diagnostics that we run live to see if we can help you in some way. So let's go to partition merge. And this will take maybe 30 seconds or so to run. But we're actually going to check, are you eligible for the preview? And let's look at all the conditions that you need to meet that are currently supported in the preview. So here are the condition. The most important one is SQL API account uses .NET V3 SDK version 3.270 or higher. So let me zoom in. That's the earliest version of the SDK that you should be on. But we actually checked for the last 90 days. What were the other SDKs that we detected on this account? What versions were they, and what was their last date? So I can see for this particular account, I actually was using version 3.11.5 on April 20th. So if I, as an application owner, I might know, oh, that was testing, I don't care about that. Or, oh no, that's a real application that I forgot about or update, or need to update.
Nice, nice. The only thing I can think of that might be missing from here is if we could get where that request came from, because as I said, having worked in banks where it runs on a machine under someone's desk, if you at least get the IP address or something of where the call came from, that could be quite useful. But no, actually having that, actually be able to tell that there is an out-of-date SDK accessing it, that's pretty powerful, because a lot of times you don't know this information. So that's very cool, love it.
Yeah, so once you're on this page, if you're interested in potentially evaluating this feature for your account, you can go to the account, use this eligibility checker, and if you are eligible, or let's say SDK didn't pass, but you know it's all testing and you don't care about that and you do plan to upgrade, just hit register for the preview down here, find the name of the feature. So this, once you hit register, it will notify our engineering team. We'll just double check all of these requirements here as well. We'll email you to ask which accounts do you want it on if you want multiple. And assuming you acknowledge it, then we will enable the feature for you.
Nice, so it's not kind of generally available to everyone. It's a preview feature. This will help you. And I guess as well, if you signed up for it, then the engineering team will be reaching out to you. So if anything goes wrong, you've got the engineering teams on hand to help.
Yeah.
Nice. Obviously, but by preview, this isn't an early alpha that's going to go wrong. This is going to be a well-tested preview, isn't it?
Yeah, we have tested this merge on several internal Microsoft customers running at scale to validate that it works. But we're still really excited to hear your feedback on the PowerShells, the CLIs, and just the overall experience. Cool. All right, so that's it for merge. Turn it back over to Justine.
Yeah, thank you. Cool, so let's take a look at another one of our new features.
Oh, it's yours. Just go down a bit.
Oh. Okay. Sorry. It's my first time using PowerPoint ever. No, I'm kidding. Okay, so on to burst capacity. So what is burst capacity? Burst capacity is another new feature also in preview that actually allows you to benefit from your unused capacity. So as you know, Cosmos DB has a provision throughput model. So this is only compatible with our provision throughput, either through manual provision throughput or auto scale. And what that means is you provision a certain amount of throughput that's always available to you, and you charge for it even if you don't use it. So with burst capacity, we now unlock the feature to use up that unused capacity that you had saved and you had paid for, but you weren't using. So this is a really great scenario. Say you have many physical partitions with a small amount of RUs, and say one of them is idle for some time, and then say all of a sudden a big spike happens on a container, and so you get 429s, right? Because you exceeded your provision capacity for that container. But
Sorry, 429?
oh yes, that is a great point. So 429 is the HTTP status code for throttles in Cosmos DB. So basically it means, hey, you tried to issue a request to me, but I actually didn't have any throughput or any capacity to actually serve that request. So it's just our code for throttling.
Right, so that's the code that if your client application hits that code, it's wait a second and try again.
Yes,
rather
exactly.
than you don't have permission or there's an error or something. That's
Yeah, exactly. So this is a
Okay.
retriable code, and hopefully in a couple seconds or minutes or whatever it takes, you will have capacity available to you. So with burst capacity, this will help you avoid this scenario, right? You're idle for some time, you hit a spike, and you're throttled. We don't want that behavior. So what are the details of burst capacity? This actually will allow physical partitions to accumulate up to 5 minutes of unused capacity. And this burst capacity that was previously unused, you can use it to burst at a rate of up to 3,000 RUs per partition. So what this means is that if you have an account with more than 3,000 RUs provisioned for your partitions, unfortunately, they won't be able to take advantage of burst today. But if you have an account with less than 3,000 RUs provisioned, you can store up your saved capacity and burst up to that 3,000 limit. So let's take a look at an example. Say we have a partition with 100 RUs, and let's say it's idle for 300 seconds. It will actually accumulate these 100 RUs for every second. 300 seconds is also 5 minutes, so this 5-minute window. And that means you'll have up to 30,000 spare RUs. So it can actually burst to 3,000 RUs for about 10 seconds because of all of this unused capacity. So any unused capacity in each second can be accumulated toward the burst capacity. And this happens on a rolling window. So it's not, every 5 minutes and then the next 5 minutes is a new window, right? It's a rolling window of 5-minute burst capacity. So let's take a look at another demo and see this in action as well. So I'm going to pop back into the portal. Burst capacity is actually enabled at the account level. So you'll notice we're in a new account now. This is our Cosmos Elasticity Burst demo account. And I have 2 containers here. So I'm going to take a look at my burst container demo. Burst container demo container. That is a mouthful.
Try saying that 10 times.
Yeah, seriously. Okay, and in my scale and settings, I'm going to scroll down so you can see that we have 1,000 RUs provisioned for this container. So this container has been sitting around idle all throughout this presentation. We haven't sent any requests to it. So we should have 5 minutes of burst capacity for this 1,000 RUs that we've provisioned for this container. So if I jump back into my VM and make sure I'm running the correct project, we can actually run a data generator that will simulate a workload against this burst container demo container. And we should see, I just showed you that we have 1,000 RUs provisioned, but if you take a look at the throughput, the numbers that we're actually seeing is 3,000. So this is because we have all of this idle capacity that we've been saving for 5 minutes, and it lets us burst above our 1,000 RUs that we have provisioned. So let's take a look at some metrics. I'm going to stop my data generator. We can take a look at some metrics in the portal that will show you how your burst capacity is actually running and being used. If I can get out of this VM, there we go. So back in the portal, I'm going to go back to my burst demo. Looks like I collapsed this tab. Oops.
Try scrolling to the left a bit.
Scroll to the left. I don't see it. Scroll.
Oh, I just find the account again in the overview.
Sorry. Let me just go back to this demo.
Oh, zoom out.
So weird. Oh, sorry. We're zoomed in too big to see the to see the blades. So I was looking for this kind of control plane that shows us all of the blades, or control panel. Sorry. So I'm going to scroll down here, and we're going to take a look at our metrics. And we can actually use the metric called total request units. And we want to use the preview version of total request units. And I can add splitting. And here we're going to split on capacity type. So this should take a second to load. And I'll just zoom into one of these areas when I was previously running this data generator. So it takes about 5 minutes for metrics to show up in the portal. So unfortunately, I can't show you the burst from the app that I just ran, but from an earlier run, we can see here, the blue line represents our provisioned capacity. So these were requests that were actually served using that provisioned capacity. And the orange line shows us our burst capacity. So we can see that for this small period of time, we were actually able to burst above the RUs that were provisioned for this account. And we can also take a look at another metric, which is called total requests. And this one, you can also apply splitting on capacity type. And we should see a really similar pattern here. And we can see that some of our requests represented by this orange line were actually served from our burst capacity. So these are two really nifty ways that you can look at burst capacity using metrics. And we have one other way that you can look at your burst capacity and really see the value that you're getting for this burst. And this example, we're actually using log analytics. So log analytics is based on diagnostics. Now, diagnostics is a configuration that you need to set for your account. There is a cost attached to using diagnostics. This is because we're logging all of your requests, and of course, it takes some time and effort to store and actually do that logging. But I'll just walk you through what this query is going to do. So we're taking a look at the CDB partition key RU consumption table. A lot of mouthfuls today. And
this is definitely not a good thing to do if you're tripping over your words.
I know.
Yeah. Do not get drunk and try and describe the Cosmos DB setup.
Right. No, definitely not a good idea. So I'm trying to really enunciate for everyone today. So I have a filter here, time generated, based on a time that we previously ran a workload. And I'm going to filter to my burst demo database. This time I'm looking at my burst container 2. And I'm just going to extend a line that represents that 1,000 RUs of auto-scale throughput, which is provisioned for this container. And I'm going to summarize two things: my request charge for this period, and I'm also going to project that max auto-scale throughput line. And then I'm going to actually bin it by the time generated for 1 second and render the time chart. So let's go ahead and run this. This will take just a second, and we can take a look at this chart. So here it's really clear to see we have all of this unused capacity, nothing was happening on our account. And then here we were able to burst to 3,000 RUs. And after we ran out of all of that unused burst capacity, we go back down to our provision throughput of 1,000 RUs. Now you can see here we have another gap in our consumption. So we were able to do another burst. And then after we run out of that burst capacity, we go back down to provision. So these are two different ways that you can take a look at the burst capacity and actually see what's going on in your account.
This is awesome. I guess a question for our audience really is, has anyone ever needed this? Anyone ever built anything where they're paying extra for that one thing a day? I mean, I'm thinking, for example, if I'm running a shop and I'm storing data with every transaction, and then at the end of the day, I want to produce a report, I don't want to be paying all day just for my report. at the end of the day. So that I could run with my burst capacity.
Yeah, so burst capacity is just enabled on the account, and it will kick in when it's available to be used. So you can't specify, oh, now I want to use it, right? It's just always there. Once it's enabled on the account, every container in the account will be able to take advantage of burst capacity anytime that it's available. And I believe burst capacity doesn't have an additional charge.
Oh yeah, it's free to use burst capacity. There's no charge for it. You can think of it as this like auto scale example. We gave you 10x scale range. You can scale between 100 to 1,000 RUs instantaneously. 1,000 RUs always there. You provisioned. But for those times where you actually need to go above 1,000, you have a sudden spike. Say it goes to 3,000 RUs. If you have some leftover capacity before without burst, anything over 1,000 RUs will just get throttled, which means that your app is slower, or that report you want to run will be slower, or might even fail if you're too resource constrained. But now for that 10 seconds or however many seconds you can get for a burst, those requests will actually go through. So now things will either go faster and you didn't have to pay more.
So if I was using this like the back end of my website and I suddenly got a lot of people signing up, if I went viral on Twitter and some people kind of piled in like, I want to sign up for this new startup thing, I would get that capacity out of the burst capacity. And obviously, if I kept on exceeding it and I started hitting the 429s, you said
Yes,
what's the 429s?
exactly.
Sounds like a boy band, doesn't it?
Yeah.
So if I keep it in 429s, I know that that's telling me that I need to increase my capacity. But that's something that obviously that's the good problem to have, because I'm getting that because I'm getting more business coming in.
Yeah.
But just for those short bursts, because somebody mentioned my site on something and people, oh, this is interesting, click on that. We've got that covered. Nice. So what I'm sensing with a lot of these features so far is you want Microsoft to make less money. I mean, you can't. I'm kind of feeling a bit bad for share price already, but
We want to make sure that Cosmos DB is a good value for money, right? So all of these features are helping you both reduce your costs, but also get more out of the costs that you're already spending today.
yes, that was. I know when I spoke to people in the past about Cosmos DB, there's always been a question of it seems quite expensive. It's like, this is a global scale database. This is not something. This is not like a spin up a cheap little MySQL database for playing. This is a global scale database. So obviously you're paying for the features. There's usually been a lot of confusion around why is it so expensive? What am I getting for it? But you're saying literally everything I've heard so far tonight has been we want to make it cheaper. We want to allow you to understand what it's doing better. If you're paying for these RUs, we want to give you if you're not using them, we want to give you the capacity to use them when you need it. And this is a tool you can use to see how it's being used, and this is the way to kind of reduce it and keep your costs down. Which certainly deals with a lot of complaints I have to say. I've heard people saying, I don't understand the pricing of this seems quite expensive. And I'm saying, no, it's not, because we've got all these cool things. I like it.
And that's another point, with the partitioning example that we showed you, for instance, I had the exact same data, the exact same setup and everything, but just by changing my partition key, it actually got a lot cheaper to run my workload. So a lot of the perceived cost of Cosmos DB is really just extra room for optimization. Right.
So this is something that I guess as part of our documentation, as part of our training in the future for people is there's a lot of things you can do to optimize this. Yeah, Cosmos DB is a relatively new product. When you compare it to something like SQL Server that's been around for decades, there are very experienced DBAs who've spent 20 years optimizing this thing so they can keep the cost down. Cosmos DB has only been around for a few years. So, the learning about how to keep costs down is still going to be very much an ongoing thing as people build up that experience. And then we're responding to that by adding a lot more features to help whatever is the SQL Server DBA equivalent for Cosmos DB to help them optimize cost. And then like if I was a startup, for example, thinking what database do I want? You look at these databases. Hey, if you do Cosmos DB, we've got these cool things that help keep your cost down, because as a startup, cost is very important, but you get the global scale. So when your startup goes through the roof, it's that click, you're now around the world type thing. So
yeah, that's
really cool.
And I think we have one more feature to demo that will also help you optimize your workload and reduce costs.
Oh, nice. That's such a nice theme here. We should have called this "How to Spend Less Money" at Cosmos DB, shouldn't we?
Just on that subject, I'll give a quick plug for 2 other features that we released previously that can also help you save costs. So we do have a Cosmos DB free tier where you can get the first 1,000 RUs for free in your account, 1 account per subscription. We also recently lowered the entry point for auto scale from 4,000 RUs 4x to 1,000 RUs. So with auto scale, 1,000 RUs is your entry point. Free tier gives you 1,000 RUs for free. You can actually put in 25 containers in there, use auto scale completely for free. If you have even smaller workloads where you don't even think you'll hit 1,000 RUs maybe, or have very low storage, but still want to store data somewhere, serverless would be a great option. Like we mentioned earlier, you literally only pay for the request units that you consume, and 25 cents per GB for storage, but that's pretty standard. If you don't send any requests, there is no RU bill. So it's a great way to also use Cosmos DB, get all the benefits, but not pay if you're not actually using the feature.
Nice, nice. I'm a big fan of free things, so this is very cool.
All right, so let's move on to talk about the last feature that we want to demo today. So this is definitely more of a power user feature. It's the ability to redistribute your throughput across partitions, which basically means you can set different RUs per physical partition. So why would you want to do this? Again, power user feature. If your app is running fine, if you're not getting that many 429s, you have, let's say, between 1 to 5% on a production workload, which is pretty good, I would say. Like, it means you're actually using your RUs. If you, one misconception some customers have is that if I see one 429, that's really bad, something is wrong. But actually, if you don't see any 429s, we only send them when you're using your database and trying to use your provision throughput. So if you don't see any 429s, that actually means you have too many RUs and can go lower. So if you have a scenario where you are actually getting 429s because you have a hot partition, where let's say you've partitioned your database in a way such that naturally one logical key or one physical partition that key is on gets a lot more throughput, requests, storage than the others, then it's going to be bottlenecked. So for example, in our store workload, if store ID 1 was the really hot store with all the traffic, and your other 499 stores have very little traffic, even if I provision, let's say 6,000 RUs for the whole thing, I'm only going to be able to get 6,000 divided by number of partitions for that one store. So your options at this point are either, let me just jack up my RUs through the entire collection, so now that's more expensive, or what if I could just give that one partition just some more throughput, right? And then not have to keep the other ones the same. So that's the scenario that this is meant to address here. Before I go to the demo, I just want to show conceptually, if you're a visual learner, what this will look like when you're thinking about how I should decide which partitions get which RUs. So let's take an example where we have 6,000 RUs provisioned with 3 physical partitions. So by default, each physical partition gets 2,000 RUs. Let's say we've identified that partition 1 is the consistent permanent hot partition, and I'll show you some metrics we can use to identify that. And let's say, based on the activity, we want to actually give it 4,000 RUs. To do that, we can take 1,000 RUs from the other 2 partitions. So now they'll have 1,000 RUs, and then this physical partition that needs more will have 4,000 RUs. So conceptually, we are taking RUs from some source partitions and giving it to our target partitions. Okay. The way we express this in code is we have a PowerShell command you can use, where you specify what are the partitions that I want to take throughput from, what should their throughput be at the end of the day. So for my 2 partitions, they're going to have 1,000 RUs. These are my source partitions that I'm taking RUs from. And then my target partition is the one I want to give throughput to. So I want this physical partition to have 4,000 RUs of throughput. And then it's just a matter of calling the API to tell us to update the per partition throughput and take from the sources and move to the targets. All right. So that's conceptually what's going on. Let's actually see how powerful this is in real life via a demo. Oh no, it's going to ask me to sign in again. Oh no. Okay, that's fine. We'll just use this tab that's already here. So let's go to my container here called throughput redistribution demo. And here I have a workload that I've basically engineered to have an extreme hot partition, where I'm literally only writing to one store ID, or typically only writing to one store ID, so I'm getting bottlenecked on one partition. I will go ahead and run this data generator. Close this one. I'll run the data generator to simulate the skewed workload. So run not this project, but this data generator project here. Okay, so let's generate a skewed workload. We're literally behind the scenes only going to write store ID 1, which we no is only going to go to one physical partition. So we're already seeing that the effective throughput is pretty low, right? In theory, we should have been able to get 2,000 RUs per 6,000 RUs across the entire collection. But because we're only writing to one partition, we're basically bottlenecked at 2,000 RUs. So those other 4,000 RUs are not being put to use.
And what are those throttles? Is that the 429s that we keep talking about?
Those are just counting every time we send a request how many throttles we're getting. Since this is a hot partition, so we're getting a lot of 429s. All right, so we'll keep that running in the background. But now let's actually live go ahead and change the throughput to give one physical partition more. So go, yeah.
Just a quick side note, you should definitely get some Cosmos DB swag that's got 429 on it.
That's a good idea.
Or maybe make 29th of April Cosmos DB Day.
Oh, actually, we were joking in our team, like, happy National Throttling Day. So here I've got my built-in PowerShell handy tool again, and I'm just going to copy that code sample we showed earlier that's going to take from the sources and give to the targets. So this is going to run it live on that same container that currently has a data generator running. So paste this. Paste.
So can you explain a little bit about what this actual query is? So we have our throughput objects and we have our sources and targets.
Yeah, so basically earlier we decided we want to get 4,000 to one partition, which is this target. And at the end of the day, after we take all the RUs from the sources, they should have 1,000 RUs left. So you'll see this all adds up to 6,000 RUs, which is the total provisioned on my container. So that is staying the same. I just rebalanced it, right? So I'll call this. This also works for Mongo API as well. So this will be like Mongo collection if you want to do this on Mongo API resources. But you'll just give it the list of source and targets. It takes a little bit, but we see once it's done, we still have our 3 physical partitions, but now one of them has 4,000 RUs. So if we go back to our data generator, we'll see it's still running, haven't touched it, but now we're still sending to store ID 1, but that underlying partition has 4,000 RUs of throughput. So our throttles are gone, and now we're getting the throughput that we actually wanted on this partition.
So what we're seeing here is, again, you don't have to take down your database while you make this change. It can happen live. So nice as an SRE or a DBA watching this, if I'm seeing all this, if I'm looking at live metrics on this, you've got my dashboard up there, and I'm seeing that, yes, in this partition, I'm getting lots of 429s and not getting over here. I can just go simple command, typey, return, and it will just sort it out for me. So, and probably again a good thing to think about planning up front is if you're gathering data from, like, say, stores, you've got like a flagship store that does, $20 bajillion of sales every day, and then you've got kind of smaller stores in other places. If it's all right into Cosmos, the smaller stores don't need all the IUs, but the big store does. The flagship store does. So it's part of understanding the business model of your business is where I get the spikes, and then you kind of build this in, and you're not paying extra for stuff you don't need. So again, it's just saving money. You're not paying for things you don't need.
Yes.
Great, it's fantastic.
So Deborah, how did you know that partition ID 1 was the partition that needed this extra throughput?
Great question. So we've got some built-in metrics we can look at to determine that. So back to the portal. So we have a couple of options. The first one is we can look at, I'm just going to reuse this container here. This is first. Oh, this is first. Okay. Actually, let me just do it on the VM one then. Okay. So we have 2 options in either log analytics or the built-in metrics. So all the built-in metrics are free out of the box. They're just always there for you. So the first thing we can look at is, do we have one physical partition that is disproportionately at a higher utilization than all of the other ones? So that metric is called normalized RU consumption. Let me filter to my collection. Okay. And I'm going to apply splitting, which is basically like a group by my physical partition ID. And you can see I have 3 physical partitions. I'll just zoom into this last bit where I was running this demo. You can see very extreme skew, which we engineered this way in the data generator. Literally 100% utilization on that one partition, right? We maxed those 2,000 RUs, and literally no requests sent to the other partitions. So this is the first sign that if we see, if we didn't have a skew, we'd expect to see all of these kind of go in lockstep. No single physical partition is much higher or lower than the others, but this one has a very clear skew. So that's the first sign that there's some kind of skew here, but we might actually want to know what is the logical partition, which store is it that's actually causing that skew. So to that end, we can look at log analytics to get more detail. So log analytics here, again, gives you at a per second level every single request that's going to your container, every logical partition key, if it's provided, how many RUs it consumed, was it a read, create, write, like super fine-grained detail. Which we typically advise turning on if you need to debug something or just have it for a short amount of time. So in this query, I'm going to filter to my hot partition container, and I'm actually going to extract out the store ID from my partition key. So the partition key, again, is here it's 2 levels, got store ID and the GUID of the transaction ID. So I'm just going to parse out the first thing in the array, which is the store ID. And then I'm going to sum and to see which of my store IDs are consuming the most RUs. So that's the summarize request charge, and I'm binning here by 5 minutes, and I'll summarize my store ID in which physical partition it's on. And then I'm going to order by highest RU charge to lowest RU charge. So if we take a look here, we can see there are multiple 5-minute windows where I consumed more than 1 million RUs for store ID 1, which is on physical partition 1. And we kind of scroll down to the long tail. Again, we were purposely only writing to store ID 1, but earlier we were writing to some other stores where you can see only around 20 RUs were being written to, let's say, some of the other stores that might be on different physical partitions. For example, store 31 was on physical partition 0 and consumed 1 RU, probably just a quick key value lookup. So this is so once we kind of narrow down, we probably have a hot partition. We can use this to further see, get more details on what in the data is actually causing this.
So we run the chart we showed off first to start with to say, yes, we have a hot partition, then we run this query, see what the partition is, then we run. So it kind of feels like if somebody's saying, yeah, we're getting a lot of these timeouts in the space of 5 minutes, somebody can literally diagnose the problem, find out which is the hot partition, and fix it.
Yeah.
Without taking the site down.
Yeah.
Yep.
Nice, nice. Yeah, I mean, I'm used to, I remember years ago, we were working in banks, we had DBAs, and we need to repartition our SQL Server database because we're running out of disk space, we need to repartition it. And that was a weekend job because we had to take the whole system offline, and then they would spend hours repartitioning it. Then we'd have to bring our systems back up on a Sunday, make sure it all works. And you're saying, yeah, no, we don't care about that. We just go, yep, look at this chart. Okay, run this query here. Yep, run this bit of PowerShell. Done. Thank you very much. Nobody notices apart from the fact we get less timeouts.
Yeah.
Nice. Nice.
By the way, just show since you mentioned these metrics and wanting to get more insights and dig into what's going on. I was showing you individual metrics in that metrics blade, but we actually have a nice built-in view called Insights, where we have a bunch of pre-built useful views for you. So if you want to search for, let's say, total requests, I can zoom in, look at this, and actually see how many of my requests I had and split by status code. So I can actually see how many 429s they have relative to my overall successful workload.
And this is the kind of thing I have up. So when I've got all my screens up around from my SRE folks, all my ops folks, all the big screens everywhere, I have this up on one of the screens, and I can see, yep, this is an issue. So it's kind of nice pre-built chart. We just click there, choose the collection, or choose the account, and there we see it. And we just look at the number. It's that, the number of 429s is there. Nice, nice. This kind of makes it really quite easy for folks, doesn't it?
Yeah.
Nice.
The goal, yeah.
Nice. Cool. Awesome. So we are almost at time. I've seen a lot of fantastic things here to help folks save money. For people who want to learn more about this, where should they go to learn more?
Great question. We've got a couple of resources for you. So we have public docs for each of these features. We have, to show you the one for merge, have all about it, all the code samples, the requirements to do the preview, how you can register, and so on. And we'll also probably have more samples and demos coming up in the near future as well.
because that's the thing, this is preview, isn't it? So
Yeah.
yeah, it's all preview. So keep checking the docs as we get more and more stuff in there. Maybe follow Azure Cosmos DB on Twitter to hear announcements. And yeah, it's all going to keep coming in. I guess we encourage people to go out and play, don't we?
Sign up for the features.
Yay! Awesome. Well, thank you very much. This has been brilliant. It's great to be unpacking some of the tech from Microsoft Build with both of you here live from the Microsoft Reactor in Redmond and online. But yeah, with that, thank you very much for your time. Folks, we have put a survey link in the chat. Would love it if you could just spend 30 seconds or so giving us your feedback. We want to know what it is you like and don't like about the events we put on at the Reactor. I'm actually standing the camera here. But yeah, we want to know what it is you like or dislike about the events at the Reactor so we can make these events better for you. The Reactor is all about your community. We want to make sure we've got the great content that you want. So please fill in the survey if you can. But with that, everyone, thank you very much. It's been great. And thank you very much to the two of you. This has been really fun.
Great. Thank you so much.
I've learned a lot.
Thank you.
Thank you.
Thanks, and thanks everyone for watching.
Thank you.